Okay. Um, let's talk about this concept of a different graphing system, right? So the graphing system that you are most familiar with is what we call the Cartesian coordinate system. It was sort of put together by this guy Rene Descartes a long time ago, where he just took one number line that went horizontal and then one number line that went vertical, and he just crossed them and came up with the Cartesian coordinate system. And the Cartesian coordinate system has been very useful in mathematics, right? But it has its limitations because it's really based on straight lines, right? So it's based on an x-axis and a y-axis and a grid of straight lines, vertical and horizontal, that create all these squares, right? That's the grid that gets created. So it gets a little complicated when you want to graph something round in a right angle graphing system, right? Just as if you can see this, I don't want to spend too much time, but why is the equation of a circle, so complicated looking? Like, why do I have to square all of these things and have all of these differences in binomials? It's because we're trying to graph something that's round in a square graphing system, okay? So what some really smart people came up with was a different type of graphing system called the polar coordinate system, okay? Now, the polar coordinate system does have some similarity to, and I guess I'm just gonna compare it to the Cartesian coordinate system, something that you should be very familiar with, okay? Now, a couple of things. So first of all, it looks like this, right? A bunch of concentric circles, all right? The origin, which you would know to be called the origin, right, which is right here, is no longer called the origin in the polar coordinate system. It's called the pole, okay? The center of the universe, if you will, okay? And we don't have a y-axis. Even though it looks like we do, we technically don't have a y-axis, okay? But we do have what's called the polar axis here. So what you would have thought of as the positive x-axis, okay, is now called the polar axis, right? So we have the pole and we have the polar axis. Now, the ordered pairs, and we do have ordered pairs, as you can see over here, we do have ordered pairs for the points in the polar coordinate system, but we don't have x and y coordinates. When you think about x and y coordinates, what is the x coordinate, right? That's how far we move left to right, and the y coordinate is how far we move up and down. So it's always about left and right and up and down when we want to plot a point, all right, in the Cartesian coordinate system. In the polar coordinate system, it's not about left and right, up and down, okay? It's about around and out, okay? And it's kind of misleading the way that we write these ordered pairs, if you ask me, and this is just the way that I see it, okay? And that is, we have theta, okay? Theta is the rotation around the pole, okay? So as you can see here, we've graphed the common angles that we normally see on the unit circle here, okay? So we have all of our pi over 6, pi over 4, pi over 3 angles. We're going to see those values in the second coordinate of this, okay? So I'm just going to say this is our, this is our around coordinate. Should have given myself more room here. That's how far we move around the pole, okay? R, this new value of R, this is how far out we move from the pole, okay? So we're going to do a bunch of examples of this. Just understand that we do have these coordinates. Now when we graph these points, okay, and take a step back, and I'm going to write this down and then I'm going to erase it, right? So in an XY coordinate system, in a Cartesian coordinate system, I don't know how you were all taught this, but I think it's pretty common for people to start at the origin, move 3 spaces to the right and 2 spaces up, and then plot that point, right? When we're on an XY coordinate system. So you're used to using, but marking off that first number first, and then you use the second, so over and then up. I think that's pretty common. I don't know very many people that look at the y coordinate and go up, and then look at the x coordinate and go over. but that's, you know, again, a preference thing, I suppose. When you look at polar coordinates, in my professional opinion, I think it's easier to go around and then out, okay? And the reason for that is because once r becomes negative, things get a little weird, okay? And I'll just leave it at that. We're going to do a bunch of examples, okay? But when you look at this ordered pair, it actually, I believe, helps if you see this number first and that number second, okay? So we're here, we might as well just do one quick example. Let's say 2 comma 3 pi over 4, okay? So what they're saying when they give you an ordered pair like this, 2 comma 3 pi over 4, is rotate this far around the pole and then move, this is the distance the point is away from the pole. That's what we mean when we talk about out, okay? So we move to where 3 pi over 4 is. Now here's 3 pi over 4 right here, okay? And then we move out 2 units. You'll notice there's still a scale that's set up here on the polar axis, okay? So these concentric circles, for every 2 circles that you move out, that's 1 unit. So at 3 pi over 4, moving out 2 units would be 1, 2. So here is the point, 2 comma 3 pi over 4. Now we still have negative angle measurements. We can still use those, okay? We can still talk about coterminal angles where we rotate around multiple times, okay? And like I said, we'll talk here in a second about what happens when this is negative, okay? Actually, we're here. We might as well talk about it. And let's just throw it down here right now. If r is less than 0, so if that leading number is negative, okay, the point, and I'm going to use some very informal language here because that's kind of what I do, okay, but what I'm going to say is the point is pushed in the opposite direction of theta, okay? So essentially, and here's a different way of thinking about it, okay, as you're writing this down. Okay, let's see if I can squeeze this all on here. Here's 4 pi over 3. So let me give you an example. Let's say negative 1 comma 4 pi over 3, okay? If we go around to where 4 pi over 3 is, right here, when the r value is negative, we don't move 1 unit in the direction of 4 pi over 3, we move 1 unit in the exact opposite direction. So this angle, 4 pi over 3, which is right here, can be thought of as a diameter that goes through, like so. So when the r value is negative, instead of going along the angle for 4 pi over 3, we actually move along the diameter in the opposite direction, okay? And so this leads us into the next idea of points representing an infinite number of ordered pairs, okay? We'll talk about that in the next video. This one's getting too long.